Welcome my dear learners for this course on engineering graphics. In this module 2 we were discussing on orthographic projection of plane surfaces. So far we have solved 18 problems on orthographic projection of plane surfaces. Moving ahead, the problem number 19 of our discussion states that a pentagonal laminae of edges 25 mm is resting on vertical plane with one of its sides such that the surface makes an angle of 60 degree with vertical plane. The edge on which it rests is inclined at 45 degree to HP. Draw the projections. We have a pentagonal laminae resting on one of its edges on vertical plane. So the laminae is resting on vertical plane. So therefore, I should draw the pentagon in the front view because it is resting on VP on one of its sides. Since it is resting on VP in the second position, I should show inclination with respect to VP itself, and is given it as 60 degree with VP. And finally, I will show the inclination with respect to HP. The edge on which it rests is inclined at 45 degree to HP, says. Now, since the laminae is resting on one of its edges, I will draw the pentagon such a way that I will get edge towards my left hand side. As you all know that we are following left hand reference to avoid confusion. Let me solve this problem. First, let us lay down such a way that edge will rest towards your left hand side. The dimension is specified. The edge length is 25 mm. So therefore, draw 25 mm. Drawn. Now use protractor and lay down the angle. Either it is interior 108 or exterior 72. Similarly, above also lay down the angle, that is interior 108 or exterior 72 degrees. Done. Now draw the remaining edges. Edge dimension is known, which is 25 mm. Similarly, above also you lay down the edge. Done. Now use compass and cut arc to complete the pentagon. From another corner intersect the previously drawn arc, connecting which I will get the required pentagon of sides 25 millimeters. The pentagon is resting on vertical plane. Let me mark this as A, B, C, D and E, E dash, A dash, B dash, C dash, D dash. The dimension is given. The edge length measures 25 millimeter. This is vertical plane, this is horizontal plane, this is XY line. Now take the projection. So if I take the projection, the top view will be a straight line, correct? The top view will be a straight line. Mark it. The top view is a straight line. This will be A is visible, B is invisible, E is visible, C is invisible. Here it is D. So I obtained the top view also. Now since the laminae is resting in vertical plane, I should show inclination with respect to VP itself in the second position. The laminae is inclined at an angle of 60 degree to VP. So therefore, draw 60 degree. Measure 60 degrees and transfer the laminae at an angle of 60 degree to transfer. Done. You also transfer the points. That is, this is E and C, this is D and this is AB, and this angle is specified as 60 degrees. Done. Now take vertical and horizontal projection and complete the sketch. Take vertical and horizontal projections. Take the projection. Similarly, E is here. This is E, and we have A and B, and also C. Done. Now connect this A to B, B to C, C to D, then D to E, and then E to again A. So this will be A dash, B dash, C dash, D dash, E dash. Done. Now finally I should show inclination with respect to horizontal plane. What he says, the edge on which it rests is inclined at 45 degree to horizontal plane. It is resting on the edge AB. So therefore AB should be inclined an angle of 45 degrees to horizontal plane. If you carefully observe, AB dash is maintaining its length constant throughout the problem. So therefore no need to go for alpha angle problem, because alpha angle is not required, because the edge dimension of AB is same as its original dimension, which is 25 millimeters. So now let me draw 45 degree line. Draw 45 degree line and incline AB dash on it. Let me draw 45 degree line for reference. Done. I have drawn 45 degree line. Now this length is known. That length is 25 mm. So draw 25 mm on this line, which is nothing but A dash and B dash. Now from here we have a perpendicular bisector, correct? Let me call that perpendicular bisector as M dash. D dash M dash is the perpendicular bisector to A dash B dash. Measure its dimension. So bisect A dash B dash, that is 12.5 mm on either side, and lay down the perpendicular bisector which you have measured. That will give us D dash. So now use compass and transfer remaining points. So we have B dash to C dash, B dash to C dash. You measure. Here also we have A dash to E dash. From D dash you measure E dash. So from D dash you measure E dash and C dash. So properly you measure and cut the arc. Connecting which I will get the required final front view. Here we have like this. So this completes the required final front view, C dash and E dash. Now take the projection and complete the drawing. Here he has specified the angle as 45 degrees. Take vertical and horizontal projection. A, this is E, and we have D, then we have C, and we have B. Correct? D is still the end. Draw D. Then we have E and C. So this is about A, B, C, D and E. So join A to B, A to E, E to D, D to C and C to B. So this completes the required problem, wherein which the pentagonal laminae is resting on VP with one of its edge, that is AB, and inclined to horizontal plane at an angle of 45 degree, and the surface itself is inclined to vertical plane at an angle of 60 degree. This is the solution for problem number 90. So this is about Y. Next, moving ahead to problem number 20 of our discussion, which states that a pentagonal laminae having edges 25 mm is placed on one of its corners on vertical plane such that the surface makes an angle of 30 degree with vertical plane, and perpendicular bisector of the edge passing through the corner on which the laminae rests is inclined at 45 degree to HP. Draw the top and front view of the laminae. We have a pentagonal laminae resting on one of its corners on vertical plane. So since we have a pentagonal laminae with one of its corner, I want to draw pentagon such a way that I will get corner towards my left hand side. So let me solve this problem. First let us have XY line. Let us draw XY line drawn. So since I want corner towards my left hand side, let me draw edge towards right. Take edge towards right. Taking edge towards right hand side, we have 25 mm drawn. Now use compass and measure exterior angle of 72 or interior angle of 108, interior angle of 108 or exterior angle of 72 degrees on either side. (108). It might enter horizontal plane. Let me take bit upper side. Take bit above. Repeat. Measure 72 degrees exterior angle or 108 interior on either corners of this line. This is 72 exterior or 108 interior. Now edge length is known, which is 25 millimeters. Lay down the edge. Here also we have the edge dimension, which is 25. Draw the edge. Now using compass, you cut the arc to complete the required pentagon such that you will get corner towards your left hand side. That's it. So joining which you will get corner towards your left hand side. So this dimension is known, which is 25 mm. Now let us call this as A dash, B dash, C dash, D dash and E dash. Also we want perpendicular bisector, because he is stating that the perpendicular bisector passing through the corner on which it rests is inclined an angle of 45 degrees to HP. So I want perpendicular bisector throughout the problem. So therefore measure 12.5, 12.5 on either side. Draw the perpendicular bisector from A. Done. Since the laminae is resting on vertical plane, the second position should show inclination with respect to VP itself, correct? So how much is the inclination of the laminae with vertical plane? Look at the problem. He has specified how much is the inclination of the laminae with vertical plane. This is A, E is visible, B is not visible, D is visible, C is not visible. This is VP, HP and X. So the laminae itself makes an angle of 30 degree with VP, right? So this itself is nothing but perpendicular bisector, correct? So let us call this as M1 because it is in first position. So lamina is inclined at an angle of 30 degrees, hence mark 30 degrees, mark 30 degrees. Done. Transfer. Transferred. Also you transfer all the salient points, that is corners and edges. We have A, E, B, D, C. This angle is given as 30 degrees, specified in the problem. Surface makes an angle of 30 degree with vertical plane. Now take vertical and horizontal projection and complete the sketch. That is, A is still here, E and B it is above, and D and C is still here. D and C. So take horizontal projection and mark the points D dash, C dash, B dash and we have E dash. So we have join, we'll get E to A to B, B to C, C to D, and finally D to E. So this is A dash, B dash, C dash, D dash and E dash. Call this as M2. Now the careful observation reveals that the initial length of A dash M1 is not equal to the second position length A dash M2. So since the perpendicular bisector is changing its dimension, we should go for alpha angle, apparent angle, because we have apparent dimension with us. The true inclination is specified as 45 degrees to HP, but we don't have true dimension of perpendicular bisector. So therefore construct alpha angle for this problem. That is, first you lay down the given angle. How much is the given angle? Given angle is 45 degree for A dash M1. So draw that 45 degrees. Let me take this way, 45 degrees. However you draw, no problem, there is no constraint. So first let me draw 45 degrees. Draw a line. So I have drawn a line at an angle of 45 degrees. Now let me take A dash as reference. Let me keep A dash here and call it as A dash. Now intersect this 45 degree line with A dash M1. Correct? Cut it with A dash M1. So we have A dash M1. That will gives us new locus. Draw that locus of M. Draw that locus of M. So this is M1, but what I want is M2. So now you measure A dash M2. So from A dash you intersect this new locus. That will give you M2. That will give you M2, which was required for me to solve this problem. So connect A dash M2 and intersect the XY line. Now you measure how much is beta. So measure the beta angle. If If I measure, I am getting beta angle as 55 degrees. I am getting beta angle as 55 degrees. So for me, beta is equal to 55 degrees. Now complete the drawing. We have A-M2, correct? Now A-M2 is a perpendicular bisector for D-C'. What is the dimension of D-C'? D-C' measures 25 mm. So therefore at M2 you draw perpendicular line 12.5 mm, 12.5 mm on either side. That is, draw 12.5 and 12.5 on either side and call it as D-C'. Now use compass to find B' and C'. From measure A', B', cut an arc. So from A' you cut another arc for E'. Now from C' you measure B'. From C' you measure B'. Similarly from D' you measure E'. Done. Now connect these points to complete the problem. So we have done with the front view in the final position. So we have A', B', C', D'. So this is E'. Now take vertical and horizontal projection and complete the problem. So it is resting on one of its corner, that is A. We have E and D. B and C. E is here and B is till here. So this will gives us E and B. D and C is still last. So this is D and C. D and C. So we have A, E, D, C and finally B. Correct? Now connect this. Connect A to B, A to E, E to D, D to C and from C to B. So this is the pentagonal laminae resting on one of its corners on vertical plane, such a way that the perpendicular bisector moving from the corner on which it rests is making an angle of beta which is equal to 55 degrees for this problem. So this is the solution for problem number 19 and 20 that's all from this lecture. Thank you all.